Bismillahirrahmanirrahim. Assalamualaikum and have a good day to Dr. Aizan. So we are from Group 3, Section 1 for Multivariable Calculus. Code subject is BEV 20303. So this is our group members, which is we include 4 team members. First one is Muhammad Anas Ajmal bin Azhar, and the number matrix is CE240187. And the second one is me, myself, Muhammad Nabi Irfan bin Muhammad Salahuddin, CE240167, the number matrix. And for the third one is Muhammad Zahwan Hafiz bin Zaipul Lizam, with the number matrix AE240036. And the last, our group member is Muhammad Sukri bin Baharuddin, with the number matrix is CE240150. So today we will represent our project for this subject. So, Assalamualaikum, my name is Muhammad Nabi Irfan bin Muhammad Salahuddin, and my number matrix is CE240167. Okay, so for, I will present the question 1, A and B. So, question 1 is evaluate the following double integral, with question 1A followed by double integral 2xy squared minus 4x power of 3 dA. With the given value of r is x more than 1 and less than 2, and y is more than negative 1 and less than 2. So from that, we have to use the double integral, which is the first one is to integrate by respect to dy, and then from that, the value, which is the value of the y is 1 and negative 1, so we have to respect to dy. And then after that, we have to substitute the value back, the 1 negative 1 value. We have to substitute back into the equation, and then we have to integrate one more time, but respect to dx. And then from that, we get the final answer is negative 28. Okay, so for this simulation, for this question, I use as a MATLAB Simulink. Okay, so I will explain step by step, line by line. So as you can see, the first one, I have to type the SYMSXY. So this line is tell MATLAB that x and y are mathematical variable, not just a numbers. So this will allow the MATLAB to do the symbolic integration. And then for the next one, for the next line, we have to define the integral, which is we have to put the question that will be asked, which is the 2x, wait a minute, which is the 2xy square minus 4x power of 3. So as you can see, why I put the stars, because the stars will represent the multiply action. Yep. And then let me finish it. And then for the next line is to okay, and then for the next line is to define the double integral, which is in this line where is the double integral will works, you know. So after that, we just put the value I equals to I, which is the operation, and then int in the bracket int, and then we have to put the what we call it, the variable, which is fy negative 1 and 1. And then for the next one is x, 1 and 2, which is the given value in the question. And then for the last step is we have to put the result, which is disp dot in bracket I, which is it will display the line before, which is the operation I. And then from there, we have to click the run, and we will get the answer down below, negative 28. Yep. And for the next question, okay, for the next question 1b, the given version is double integral with the function x plus y dA. So and the given value for y is 0, y equals to x square, and x equals to 1 over 3. So with that, we get with the first step is to integrate respect to dy, and we get xy minus y square divided by 2 with the value of x2 and 0. And after that, we get to integrate by respect to dx, which is we get the answer is x power of 4 divided by 4 plus x power of 5 divided by 10, and with the given value of x is 1 over 3 and 0. So we substitute it back, and we get the final answer is 17 divided by 4860. Okay, so for the simulation part, it's just the same. I use the same code platform, but I just changed the second line, which is we define the integral, which is I have to put the value, the question given, which is x plus y, the function. And then next one, just change the double integral compute, which is the given nilai x and y. So from that, we will get the answer. Because both question is operates as the same double integral, so that's why I don't need any coding. So from there, I get the value is 17 divided by 4860. So that's all from me. I will pass to the next presenter.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azhar Hafiz, and today I will demonstrate to you all how to evaluate the second question using my manual calculation and my simulation. So let's get started. So the question 2 asks we to define the double integral x square y dA, where r is the upper half of the analysis bounded in between x square plus y square equals to 1 and x square plus y square equals to 4. So for the first step, we have to analyze the region R. So we know that region R is bounded between x square plus y square and equals to 1 and x square plus y square equals to 4. And so from the formula, we will know that x square plus y square is equals to r square. And so we will get 2r from the which is from the first equation, we will get r square equals to 1, and for the second equation, we will get r square equals to 4, and finally we simplify and we will get r equals to 1 and r equals to 2. So we will know the analysis will be between 1 and 2. And for the second step, we have to convert to the polar coordinates, so that we know Rs is equal to r cos theta, y equals to r sin theta, and dA is equal to r dr d theta. And so when we substitute into the x square y, and we will get r cos theta square, r sin theta. We simplify it and we will get r cube cos square theta sin theta. But we also left the dA, so we will substitute the dA also, and we will get the final answer is r4 power of 4 cos square theta sin theta dr d theta. And so since we got the analysis is between 1 and 2, and we will know the angle theta range is only between 0 and pi. We have the next step, we have to set up the integral part, and so we know we can separate the integral between two parts, which is radial part and angular part. And so for the first one, we will separate the endless part 2 and 1 to the r power of 4 dr, and theta to 0 to the cos square theta sin theta d theta. So for the angular triangle, we will simplify the endless part, and we will get r5 over 5, 2 and 1. And finally, we will get the answer equals to 31 over 5. And for the radial part, we have to use the substitution method, which is we have to let u equals to cos theta and du equals to negative sine theta d theta. And we will get when theta is equal to 0, u equals to 1. And when theta is equal to pi, and u will equals to negative 1. So when we substitute, and we will get negative 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 1, integral negative 1 to 1, u squared du is equals to 1, integral 1, negative 1, u squared du. And after that, we have to simplify it using the integral, and we will get u cubed over 3 power of 1 equals to negative 1. We simplify it, and we finally will get 2 over 3. And after we will get the angular part and radial part, we multiply it together, and finally we will got the final answer is 62 over 15. Okay, so for the simulation part, I'm using the MATLAB to solve the answer. So for the first one, we have to define the symbolic variables. We have to key in the r and theta, which is the region and theta. And for the next one, we have to define the integrand in polar coordinates. So we have to put the equation, which is x squared y, x power of 2 and y, and convert it to the r cube cos square theta sine theta. And finally, we have to put dA is equals to r dr d theta. And so for the next step, we have to define the limits. So we have to put the region for the lower boundary and upper, which is 1, 2, and we have to put the theta range for the angular parts. So which is 0 to pi. Okay, so for the next step, we have finally to compute the double integral to solve the double integral, and we put the result and to get the final answer and display the result. Okay, so after we have done, and we get the value of the double integral, which is 62 over 50. So the answer of the simulation is also same as the manual calculation. So from the calculation, we can conclude that result of the manual calculation and the simulation is also the same. Okay, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Anas Azmal bin Azhar. Entry number CE240187, and I will present about uh, manual calculation. So first step is we write the surface area formula, which is double integral square root 1 plus dz over dx square plus dz over dy square dA. So we will assume z is equal to x square plus y square. So second step, we will find the partial derivative. So dz over dx will become 2x, and dz over dy will become 2y. So when we substitute into the formula, we will get square root 1 plus 2x square plus 2y square. So we simplify it, it will become square root 1 plus 4x square plus 4y square. So the third step, we will have to determine the region of integration. So the surface is below the plane is z equals to 1. So x square plus y square is less than 1. And then we have to convert to polar coordinate. So since x square plus y square is equals to r square, so 1 plus 4x plus for x squared plus 4y squared is equal to 1 plus 4r squared, and dA is equal to r dr d theta. And then we set up the double integral. So the first integral we start from 0 to 2 pi, and the second one is from 0 to 1. So the next step is we will let 1 plus 4r squared is equals to u, and when we differentiate the 1 plus 4r squared, it will become du is equal to ar dr. So when we integrate the first part, we will get 1 over 12 times 5 3 over 2 minus 1. So the last one we will integrate with respect to theta. So the final answer we get is pi over 6 times 5 square root of 5 minus 1. So for maple simulation, first one we will define the surface z, which is z is equal to x squared plus y squared. And then next we will compute the partial derivative by using this line, which is cx and zy. And the next step is we use surface area integral, which is we have to find the surface area. So by using the square root, 1 plus zx2 zx square plus zy square. And then we will convert to the polar coordinate by using this line. And we apply the double integral line to get the answer. Lastly, we will get the answer is pi multiply with negative 1 plus 5 square root 5 divided by 6. So the answer from the maple simulation and from manual simulation is similar.
Hi, my name is Muhammad Sukri, metric number CE0150. So for the question number 4, by using the triple integral, find the volume of solid G bounded by plane S plus Z equal to 1 and Y equal to x squared and Z equal to 0. So first we need to draw the plane in 3D graph to get a better view in order to find the limit in x, y and z direction. After that, we get the limit in z direction is from 0 to 1 minus y, and in y direction we get from x squared to 1, and in x direction the limit is from minus 1 to 1. After that, we integrate the innermost first with the respect to z, and the limit from 0 to 1 minus y, and then we integrate 1 minus y with respect to y, with the limit is x squared to 1, and the value is 1 over 2 minus x squared plus x power of 4 over 2. Lastly, we integrate it with the respect to s with the limit from minus 1 to 1, and we get the final answer is 8 over 15 unit cube. Next, for the answer verification for the question number 4, I use MATLAB software because I already familiar with it. First, we use the sims function to declare the variable s, y, and z. After that, set up the triple integral starting by innermost. One is the function to integrate. Z is the variable of the integration. 0 is the lower limit, and 1 minus y is the upper limit. So that goes same with the middle and outermost integral. So the triple integral will be like this. Lastly, function fprintf used to display the output value, with char is character string to show the output value in fraction, and then the double used to show the output value in decimal, and we get the final answer verification is 8/15 or 0.53333.